Alright, so let's see this third question. It says resolve 3x plus 2 over x plus 2 x minus 5 into its partial fractions. So of course we're used to put some things now quickly. So we're going to have what? We have 3x plus 2 over x plus 2 x minus 5 is going to be equal to a over x plus 2 plus b over x minus 5. So we add this up together, we have x plus 2 x minus 5. Then we have a open bracket x minus 5 plus b open bracket x plus 2. We have it to be 3x plus 2 over x plus 2 x minus 5. So this works like that, and we are going to have 3x plus 2 equals to a open bracket x minus 5, then plus b open bracket x plus 2 as well. So in this case we only compare the numerators. We did not work with the denominators because they are equal, and then we solve this normal because we know the LCM, and then when this divided by this, we're going to left s minus 5 which multiplies a, and then this we have s plus 2 which multiplies b. That's how we have this. So like I said, I'm only going to use the newer method here. Of course, for any question you need to solve, you can choose to use any method you want to use as far as it could work. I have explained where we have a limitation of the first method here, and that limitation doesn't have here. When we have anything with the power of 2 or 3 or anything, it's only when it is linear that we use that method, that first method. But here I want to use the general method, so that we are kind of used to it now. So we have 3x plus 2 equals to, let's open the brackets, we have ax minus 5a plus bx plus 2b. So we have it still to be 3x plus 2 equals to, let's put the things that have x together, we have ax plus bx minus 5a plus 2b. So what do we have here? We have 3x plus 2 equals to, we have what? A plus b, then we have x. So what do we have here as well? We have it to be minus 5a plus 2b as the other one. So by comparing coefficients, we know that a plus b must give, which is the x, must give us this 3, which is our equation 2, the equation 1. And we also have that minus 5a plus 2b minus 5a plus 2b must add up to 2, which is our equation 3. So in order to solve this simultaneously, let us say we want to eliminate b. We must ensure that the two of them have the same coefficients. So that means I can just multiply this one by 2 and multiply this one by 1. So I will have what? 2a plus 2b equals to 6, and minus 5a plus 2b equals to 2. So I have these two to solve. So what do I do? Since the signs are the same, I can subtract. So 5a minus 2a minus 5a will give me 7a, I suppose, because that's the plus. 2b minus 2b is 0, and 6 minus 2 is 4. So by the time I divide by 7 and 7, I have that a is equals to 4 over 7. So I can substitute in equation 1. See, substitute a equals to 4 over 7 in equation, equation 2 here, not equation 1. So equation 2 says a plus b equals to 3. So I have 4 over 7 plus b equals to 3. Then I know that b is definitely 3 minus 4 over 7. So which is 7. 7 divided by 1 is 7. 7 times 3 is 21. Minus 7 divided by 7 is 1. 1 times 4 is 4. So that's going to be 17 over 7. So at the end of the day, a is 4 over 7 and b is equals to 17 over 7. So we plug it into our partial fractions here. We're going to have that 3x plus 2 over, I think, x plus 2, x minus 5. I suppose, yes, that was it. It's going to be of a. What is a? A is 4 over 7. So that is 4 over 7, open bracket, x plus 2, then plus, what was b? We got b to be 17 over 7. So that is 17 over 7, open bracket, x minus 5. We could further on to actually say this is what 7 is common in the denominator, 1 is common in the numerator. To say 1 over 7 is common, and say this is going to be what 4 over x plus 2 plus 17 over x minus 5, and that's our answer as well. You could decide to leave it like this and you have your full mark, but if you show yes, I know what I'm doing, you could also come here to leave it like this, and that is it. So this is a standard work in solving a partial fraction problem, and like I've said, you could decide to use this method, or you could decide to use this method that I initially showed you in your method 1. If I were you, I would decide to practice this method well, this standard method, because it works in all cases. I will practice it well so I'm good at it, while also keeping in mind at this how to solve it, because this one seems to be faster than trying to solve a simultaneous equation. But that's just me anyway. You don't have to listen to me on that. It's just a suggestion, not a particular way of solving. But that's just it, and hopefully you've been able to understand the beginning part of this topic that has just started. We have just talked about the first type of resolving partial fractions, the first type, which is your non-repeated linear factors at the denominators. In the future classes and videos, you'll be having the other types as well. So that's pretty much it for now.